Hello, Geometry Genius in your former years, but now you're currently a Pre-Calc Pro. At one point, you were also an Algebra All-Star. Now you're Pre-Calc Pro, anything like that. With 3-4, taking exponential and logarithmic equations, we'll be solving now. We'll get some answers. We finally go back to x equals some number. Those are all cool. We'll see two approaches that we can take when solving equations with exponents and logarithms, the one-to-one properties and cancellation properties. Well, what does this mean, one-to-one? This says that if we have a function that's one-to-one, then when f of x equals f of a, that implies that x equals a. So it's as if the inputs would have to be the same, which is a little weird to think of. But for this example, if we had 2 to the x power, and this was equal to 2 to the 12th power, that would be pretty easy to spot that x, being the exponent, should be equal to 12. And then the equation's done from there. For some of these, we'll have to rewrite them to get common bases, and that's really the main thing to take away here, is that we're rewriting to end up with a form like this. Notice the bases are the same. That's a lot easier to work with. So we'll take these out one at a time. So with this one, we have 5 as our base here. We have 5 as our base here. So this is pretty easy to just say 3x plus 2 will be equal to x minus 7. So if we solve this, getting rid of x's, moving the 2 to the other side, this is going to leave 2x. This is negative 9. If we divide by 2, x is going to be equal to negative 9 halves. Pretty simple. In this case, simple, because again, the bases are the same. But this isn't always the case. As we see here, we have 10 as our base now, and this is equal to 1 over 1,000. In the previous sections, we saw that we could rewrite this. So what if we change this now to a base of 10? What would this new exponent have to be? Well, I know it's negative because it's a fraction. And I know that 10 times 10 equals 100. So 10 times that 100 is going to be 1,000. So this is going to be probably 10 to the negative 3 power. So notice now our bases are the same. We can now set these two exponents equal to each other. If we treat this like a trinomial, get all 3 terms to the same side, we can then get to a situation that looks like this. So we could solve this. I think we're going to have to use quadratic formula because this isn't going to really work out well. Yeah, we had to add the 3. Those were equal to each other. So you would use quadratic formula at this point. So it would be negative b plus minus square root 4 minus 4 times 1 times 3 all over 2a. So this would have an imaginary number for the answer, but that's okay. Hopefully you looked at this and said, oh, that's probably not going to be factored out well. And that's the case here. We'll jump ahead to the actual log situations now. Let's see if we can find a good one. Oh yeah, there we go. So now dealing with the log situations, these can be tricky because we want to have the log set equal to some number. We can then go about rewriting to exponential form, hopefully, which cancels out the log, and then we get that x equals a, which was our base, to some exponent b. So we'll focus on this one seen here. And this is going to recall the properties we saw previously, where if we see logs subtracting, we want to treat that as if the insides are dividing. And if we see logs adding, we treat that as if the logs inputs are multiplying. So recall, this is from the previous section. So I see that we have log base 2 of x plus 9, subtracting log base 2 of x minus 5. This is equal to 3. If we look at this, this is subtracting. So I know that I can rewrite this as 1 log with base 2 with x plus 9 over x minus 5. And this should be equal to 3. So notice what I did here. I was subtracting the 2 logs with the same base. I'm allowed to rewrite this as a quotient. Well, if we look back up here, this is saying if we have a log on its own and it's equal to some number, we can go to exponential form. So let's do that. And the whole goal being is that we want to break away from the logs. So if we take this 2, throw it over here, x plus 9 over x minus 5 is equal to 2 cubed. So this is really 8. Sorry, minus 5. If we multiply both sides of this with x minus 5, x minus 5s will cancel here. We get x plus 9 equals 8. X minus 5, distribute that 8, gets you 8x minus 40. This equals x plus 9. And keep going to solve for x. This gets you 49 equals 7x, so x equals 7. One important thing about this, although this is definitely our answer, is that we want to check for extraneous solutions. So, for example, if we were to plug back into our equation here and the input's 0, then it's an extraneous solution. So if we plug back in whatever our answer was and we end up with log of 0 or log of some negative number, we don't want to use it. So keep that in mind as we move forward. And we'll try this one out. Now with log base 10, we see that we're adding. We can treat these as if they're multiplying. So with x, and then x minus 3 should be equal to 1. If we rewrite this, this is log x squared minus 3x, still with base 10. If we now go to exponential form, because we can, this is going to claim x squared minus 3x equals 10 to the first power. So then x squared minus 3x minus 10 equals 0. And then can we factor this further? Sure can. X minus 5, x plus 2 equals 0. So this is going to claim that x could be equal to 5 or negative 2. But let's look very closely, because this is claiming we have 2 answers. Are any of these extraneous if we were to plug them back into here? Negative 2 would be extraneous, and I'll explain why. If we were going to check our work, we would end up with log negative 2 plus log negative 2 minus 3 is negative 5. And right off the bat, this can't happen. So we would say that negative 2 is an extraneous answer. We actually don't want to use it. So we would really just say that our answer in this case is x equals 5. I hope this was helpful. It can seem a little tricky if you don't recall the properties, but if you need to look back at those, please do so. If you have any questions, bring them to class. Thanks for watching.